Hello everyone, my name is Olena Rubanenko and I wanted to present you our research entitled Study of Double Short Circuits on Earth in 10 kV power grids with isolated neutral and with high level penetration renewable energy sources. Our team consists from 4 people who work in this project. Me, Olena Rubanenko, Milan Belik, Chief of Department Ecology and Environmental, University of West Bohemia, and Professor Rubanenko, and Associate Professor Inna Vishtak from Vinnytsia National Technical University. So, our project consists from 4 types. It is introduction, importance of distributed sources of generation in time in war, analysis of 10 kV network damage data, and analysis and presented simulation of the mode of a 3-phase 110 and 10 kV network in MATLAB. So, just want to maybe remind you how work our equipment, and if you speak about new equipment, similarly we must know that some infant period exists. We speak about a lot right now, a lot of useful life, and also try to control it our equipment in this time. So failure rate in this time not so big, but we have also problem in the C part, in this wear out, because our power grid, how it's noted in a report in 2021 years, and probably in war times it is not start to be better, so it is wear out time. In this reality, we must analyze this work in our power grids. So, the analysis of damage and experience of operation 635 kilovolt networks allows us to make the following conclusion. First, we must eliminate places with weakened insulation as an aging process. It is a requirement perfectly work disconnection, and also we must have possibility to disconnect what network elements. Second, a significant share of damage in network is damage to support and through insulators and switching devices. Specific damage of switching devices from internal overvoltage is quite high and only 3 times lower from lighting overvoltage. So, in this case, important also to speak about important distributed sources of generation in times of war. So, if to take into account condition our transmission lines and that a lot of attacks we have in the centralized power sources, for example, heating power plants, condensing power plants, hydropower plants. In this case, the green energy market is developed rapidly because more and more people understand and want to pass on our world to their descendants in the least good of condition as we receive from our parents. And a lot of owners start to install the distributed power sources. Also, in an interview with Chief of Olena, Yuri Kasic was noted that distributed power sources also to propose us some energy efficiency and energy safety, because it's stupidly to try attack a lot of shared power sources. It is more expensive than to attack just big power station. Okay, so, but it is not really to say that distributed power sources also not damaged a lot of, but this damage not can to be so crucial how for power grids or power system like a big centralized power station. The lower the voltage class of power lines or substation, the greater their number. So it's less known to the aggressor and not possible to note it and understand well allocated a lot of them. But if you analyze of 10 kilovolt network damage data, it's necessary to classify it in 2 times. First in overhead network, second in the cable network. Damage to line poles. Overlapping could damage to insulation on poles. Damage to cable coupling during the transition of overhead lines to cable lanes. It is everything more popular for overhead network. For cable network, damage to insulation of substation, damage to terminal and connection coupling, damage during excavation work in the vicinity of cable row, damage to cables, and so on. For one case, in the wartime, overhead network can be more damaged, but also in cable network it's more difficult to understand and find place where it's damaged, and they're also quite old and not change a lot of times. In this slide you can see diagrams of damage to power lines with voltage 6 and 10 kV. So how you can to see in the one phase and one phase, and the grid is more popular, and the most frequent types of internal overvoltage in 635 kV networks is overvoltage associated with single-phase earth faults, accounting for up to 80% of all. So, in this slide, next slide, you can see what schemes we want to present it. It is current oscillogram obtained during scope. We work with really very easy and similar schemes. You can see three load in different loads, so it's unsymmetry, and q1, q2, q3, it is breakers what we can to control our equipment and to save. Okay, the calculated values of the maximum current protection setting for phase A of the first lines, phase B of the second lines, and for the input switch. And also in the next slide we see how it's work, because all this result is modeling and simulating not real grid but in simulated grid in MATLAB, which simulated in Simulink, but use real distance, real location, and so on. These graphs show what value of the delay time in the operation of the recloses should be set. Take into account the time of the selectivity degree to ensure error-free operation of the protection and so on. The time selectivity degree of the recloses takes into account the operating time of the circuit breakers and the error of the time relays. According to the graph, the delay time in our case it is 0.05 seconds, and the transient process end and steady state short circuit mode begin. So in this case, we must to understand and calculate where really must to start our relay protection, how it's calculated, and how correctly to design relay protection. A lot of other software possible use, not just Simulink MATLAB, but if we want to more precisely see and try to simulate mode, in this case, Simulink MATLAB give us a huge instrument and huge device. So, based on the result of calculation of the parameters of 10 kV power transmission lines considered in the work, it is determining that the tripping current is equal 300 ampere, and the power supply action on the input switch on the substation to which the 10 kilovolt power lines is connected is equal 1323 amperes. So obtained model can to help us to recalculate similar schemes and give us possibility to design our grid with take to account high penetration renewable energy sources. Thank you for your attention. If you have any question, you can write an email or to give me directly.